we're asked to use the intermediate value theorem to show that for this particular function, there exists a value of xc, some value, such that f of c is 1,000. Okay? What do you think we have to do first?
Find the interval where state the intermediate value theorem.
I'm given a function, I'm told f of c equals 1,000. So how do I combine this into something that I can write that makes sense?
F of blank is less than.
Someone was already on the right track. What do you think?
There exists a number.
You would subtract 1,000 from the function.
On the right track, however, how do I write? Go ahead.
Equals 1,000.
Of course. So this is the information I'm given in the fact that I'm given the function, and I'm told f of c is 1,000. I'm asked to find c, or show that the c exists, actually. I can't really find c, not with what we know so far in chapter 2. But I'm asked to show that this has a solution, right? In other words, f of c is 1,000. So I created this equation in which I had on the left-hand side f of c, and on the right-hand side 1,000. Good. What now?
Put it
Right.
in terms of x,
If you want to change it back to x, it's fine. We can.
or subtract 1,000.
I have to subtract one side. Yes.
Let's say to the right of the 10, top left.
Sine.
Oh, sine. And it's that sine x over there.
If this is c, I cannot put x.
On the one up above. So the one, that one.
X squared plus 10 sine x.
Okay.
Good. So I'm going to denote now by this, by g of c. Right? Is g of c continuous? If it's not continuous, we cannot apply the intermediate value theorem.
Yes.
Yes. Continuous as a polynomial combined with something else, with sine. So I will say as a combo of what? Continuous functions. Everywhere. On everything. They are continuous on everything. Good. Step 2. I have to find the g of whatever and g of whatever. I haven't found those yet. So I go to the graphing calculator. And in y equals, punch in x squared minus 10, no, not minus, plus 10 sine x, close the parenthesis, minus 1,000, and go to second and table because I think it, no, okay, this one stays. Second and table. Okay. I do see something here. Okay. You don't probably not do that, but if I want to graph it, I doubt that that was, I think that that was a remnants from something else, okay, because it's a minus 1,000. So I'm going to try to analyze this a little bit before, because I don't know where the viewing window is. So I don't want to just punch in numbers. So how big is this, for sure? Because I have to figure out a viewing window in the calculator, and not just punch in numbers. So how big is this?
It can only go between, well, it goes between 10 and negative 10.
Yes, because sine alone is between -1 and 1. So this is positive 10 or negative 10, and then I have negative 1,000, negative 1,000. So now it depends on what I plug in here, right? So this is basically close to negative 1,000, and this is negative 1,000, very close. So these ones are both negative 1,000, roughly. So now I'm trying to figure out, so c squared can be anything between 0 and infinity, because no matter what I do, right, no matter what I do to c, it's c squared. Whatever I plug in c, it's c squared. So if this quantity is plus or minus, no, not plus or minus, it's definitely minus 1,000. So this is c squared minus 1,000. So, and c is definitely between 0 and infinity. So what can c squared plus 1,000 be? Minus 1,000 be? So I will look definitely on the positive side between 0 and, so if I factor this, right, roughly, so for 100 will be c minus 100, c minus 10, c plus 10, but it's 1,000. So the square root of 1,000 is what?
31.
Right, exactly. So c plus the square root of 1,000 and c minus the square root of 1,000. I'm just trying to figure out a little bit what viewing window to use. Okay, so let's go to second table. So I'm going to start with 0, 1, just a little bit to see where it's going. Okay, and then I'm going to jump to 20. Okay, and then 400. Okay, so I cannot use between 20 and 400. I have to use a 1 unit length. So I narrowed down between 20 and 400. So obviously 20 is way too small. So I'm going to go to 300. Okay, so I'm going to go to 200. Because I want to show that C is within 89 and 90, not between 20 and 400. I know there is a solution, obviously. There is a solution. Because the function is continuous and it changes sign. The numbers are big because of that 1,000. That's what the problem is. So where am I? So it's 200. Okay, let's say 100. Even 100 is big, yes. Okay, so let's say, and I had 20. Okay, let's look at 40. Okay, it's more human now, close to 600. Okay, so 40 is still positive. Let's say 30. Okay. So I narrow it down now between 30 and 40.
Oh.
Sorry. And you're so peaceful and patient. I'm so sorry. My apologies. I was talking to myself here. Okay, so I put in the function x squared plus 10 sine x minus 1,000, and I'm trying to figure out and get a close and 1 unit length interval in which, let's say, at 29 is positive and at 30 is negative. So that's what I'm trying to do. So I found that I narrowed down from hundreds to 40 and 30. I should have done that from the beginning because the square root of 1,000 is closed. Okay. So let's say it's negative at 30 and positive at 40. So I'm going to say 35. Okay, I'm close. I'm going to say 34. I'm going to say 33. Okay. So let me go back up, because very soon I'm going to get out of the screen. Okay. So I'm now between 30 and 33. So let's say 31. 31.
It's still trying to
Sure.
scroll up.
Okay, 31 is negative. 32. Finally. So it's between 31 and 32, and we should have expected that because of the square root of 1,000. So I will say, now I can write. So 31 is negative 43 roughly, and 32 is approximately 29.51. So obviously I will say that by the intermediate value theorem from 1 and 2, we conclude that there exists a C in the interval 31, 32 such that f g of c is 0. So we can always turn around and make the f of c or f of x equals 1,000 into g of c equals 0 by subtracting 100 from both sides. Very good question. Thank you. Next problem, next question before we go back to our previous work. Anything that you would like to ask? Is there anything that you worked on, anything that you would like to go back to? Anything? Tom, is this okay? Joe, I thought you raised your hand. You had something?
I was gonna go with that.
Yeah. We're going to do that.
I was referring to the character question together.
That's
I
okay.
was wondering, like, when do you decide it's necessary to go to the squeeze theorem?
Oh, very good. Very good question. All our examples basically use a sine or cosine because for the squeeze theorem, because this is the sine and cosine are bounded functions. In other words, by bounded we mean there is a minimum and there is a maximum. So for both sine and cosine, the minimum is -1 and the maximum is 1. So when you see something like sine and the inside function is undefined. So for example, if I have, let's say, the square root of x and then cosine pi divided by 2x, this is pretty close, right? It's, I mean, not pretty close, but this should trigger your memory and say, obviously, this is an x approaches 0, this is approaching 0, and this is undefined. I can't determine anything. So pi divided by 0 is what? I don't even know what it is. It's undefined, or if it's from both sides. If it's from one side, it's still infinity. What is cosine of infinity? We can't determine that. Unless you're specific, I know cosine exists from anything, but if you're not specific, I can't give a number. And we cannot conclude that 0 times something, whatever, is necessarily 0. So that would be an indication. Yeah. Good, very good question. Anything else? Have you worked on and finished this? Are we done with the checklist? Because I have to post solutions tonight. So whatever you finished, you have to turn it in because I have to post solutions for everyone to work on the solutions and prepare for the test, right? Okay, so let's go back then to this. Okay, are we continuing with the second one, part B? Any suggestions on part B? How do we address this limit? Limit from e to x minus x squared when x approaches infinity. Any suggestions? Where do we start? What do we do? This is a limit of a function. It's actually a function composition. There is an inner function and an outer function. Where do we start? The inner function, very good. So when x approaches infinity, where does this go? Just this. What do you think? X minus x squared, which one is more powerful? Good. What is the sign in front of x squared? Good. So when x approaches infinity, where will this go? Very good. Awesome. So now we have to figure out what happens to e to negative infinity. So this is not a legitimate mathematical writing, to be exact, but let's say e to negative infinity is the same with,
1 over x
very good, perfect. And where does this go?
to 0.
Very good. So then what is the answer here?
0.
That's it. What do we conclude when we determine the limit of a function as x approaches infinity or negative infinity and the result is a number? What does that say about e to x minus x squared?
Horizontal.
Very good. Y equals 0 is a horizontal asymptote at infinity. Perfect. Any questions on this? Does it make sense? Okay. The next problem, we have limit x approaches 2 from 2 minus x over the absolute value of 2 minus x. Does anyone complete this one? Okay. We're asked to completely simplify the function first before we discuss the limit. So I start with the absolute value of 2 minus x. How many options are there for the absolute value of 2 minus x? 2 options, very good. And what is the first one? If, don't solve it, just write it first. If what?
X is greater than or equal to 0.
That's why I said don't solve it yet.
2 minus x is greater than or equal to 0.
Very good. Because when you move x to the other side, you will have x less than or equal to 2. That's why I highly recommend, this is twisted. It has a negative leading coefficient. So you cannot assume what happens here before you write it. So I move x to this side and I'm reading it from the right. So x less than or equal to 2. What is the other option? And do not distribute. The opposite of 2 minus x, if, and there is no need to write anything here. If this is to the right, to the left, this must be, yes. So for the second one, don't waste your time. Once you solve the first one correctly, the second one must be the other side. Good. So this piece has 2 options. Because this piece has 2 options, the entire function will have 2 options. So 2 minus x over the absolute value of 2 minus x will have 2 options. So here's the first option. 2 minus x over 2 minus x. What is the answer? 1. If I cannot use the equal symbol because now less than 2. What is the second option? When the numerator is 2 minus x and the denominator is negative 2 minus x. Do you all agree with negative 1? Do we all see it? If what? When I'm asked to find the limit from either side of a piecewise defined function, I have to show both limits. So limit as x approaches 2 from the left and limit as x approaches 2 from the right. 2 from the left, from which function?
Left is going to be the top.
Which is?
2 minus x. So it, or 1.
Very good. And the limit is? 1. So limit as x approaches 2 from the right, from which function? Good. And the answer is? Good. So finally the answer here is? From the left is one thing, from the right is one thing. So from either side is? From the left is 1, from the right is negative 1. Any questions on this? Okay, next one. We have limit of 1 over t minus 1 over t times t plus 1. Limit as t approaches 0, 1 over t minus 1 over t, t plus 1. Okay. When we're asked to find the limit, what is the first thing? I didn't do it here because I was asked to fully simplify the function first. That's why I didn't plug in 2. It's still 0 over 0. But I didn't plug it in because I was asked to simplify it first. Okay, what now? Yes, however, in this case, it won't tell us anything because it's undefined minus undefined. And that's impossible to determine. So I will have to do something else first before I go back and plug it in. What is that something else that I must do? Thank you very much. That's the only thing, right? There's nothing else I can do here. Good. So what is the LCD? Awesome. So I need adjustments for the tops. If I choose the denominator to be t times t plus 1, then the numerator of the first fraction must be multiplied by
t plus 1.
Indeed. And the second one by?
Oh, wait, no, by nothing.
Exactly, by nothing or 1. Perfect. Good. So please dictate.
So it's t plus 1 minus 1.
Perfect. So these two go away. Now when I plug in the numerator, I get, when I plug in the denominator, I get. Before we look at this, would you tell me which is the problem factor that must go away? If the limit exists, a problem factor must go away from the top and bottom. Which one?
Just t.
Exactly. T is the problem. T minus this number. So T is the problem. So I'm hoping that I can remove a T from the top and a T from the bottom. And here it is, right? I'm going to write it one more time. So T over T times T plus 1. Remember the remainder theorem and the factor theorem. That's why. Okay, so I'll simplify. And now, only now, I can drop the limit operator. Please, please do not drop the limit operator till the very last step. And this is it. This is the step in which I can drop the limit operator. So the numerator approaches,
1,
the denominator approaches,
1,
very good, which is
1.
good. Perfect. This is it. Next one is limit as x approaches 3, the square root of x plus 6 minus x over x cubed minus 3x squared. Okay, what is the first step here? Yes. What do we get at the top?
0,
Good. What do we get at the bottom?
0.
Good. So without even looking, we know that we are after a particular factor that we hope will go away from the top and will go away from the bottom. Which factor?
X minus 3.
T minus 3 or x minus 3? Indeed. X minus 3. Because x minus 3 is the problem. We plugged in 3. We got 0. So the factor must be x minus 3. Perfect. So what do we do next?
Multiply by the conjugate.
Very good. And the conjugate will be?
Square root of x plus 6 plus x.
Very good.
Over the same thing.
Very good. Awesome. So this is limit. X approaches 3. Now, before I write the denominator, I would like you to tell me what to do to this, and then I'll write it. Very good. So x squared, what is left in parentheses? Good. Perfect. And now, can anyone dictate the numerator?
X plus 6 minus x squared.
Very good. Awesome. Good. Okay. I will continue now. And where is my focus next?
top.
Yes. First, I have to arrange it in descending order and factor out the negative leading coefficient. So please tell me what to write.
-1 or negative.
Good?
X squared plus X plus X.
Careful. Very good. Very good. Is that clear, everyone? Yes? Okay, now we're ready to factor. Always remember, among other things, we don't distribute the factors in the denominator. Number two, we always want polynomials to be arranged in descending order and no negative leading coefficient. And I can always factor out -1. Okay, so the next step would be to factor the top. So limit as x approaches 3, negative in front. How do I factor the top?
So it's like X minus 3X plus 2.
So what was the factor again that we were expecting to get rid of? That's it. Can we get rid of? And now we can drop the limit operator. So what do we get at the top?
Negative X minus 2.
We're dropping the limit operator because there is no indeterminate case anymore. Now 3 is in the domain of this function. I can plug it in. That's the rule for polynomials and rationals, where the function is defined. So the numerator goes to -5, and the denominator goes to 9 times 6. Very good, 54. Any questions? Any questions? Okay, next one. Limit square root of x squared minus 9 divided by 2x minus 6 as x approaches infinity. Okay, so I'm given a limit. I'm trying to see if I can plug it in and what type of case this is. So the numerator goes to, the denominator goes to, good, so there is hope. Infinity over infinity, 0 over 0, there is hope. It's an indeterminate case. All indeterminate cases are, hope exists. We cannot guarantee anything, but in an indeterminate case, the limit may exist. Good, so then what will be the next step? What type of limit? What type of function is it? It's a combination. It's a rational function with a square root, and yes, I agree. However, how do we address this?
That's a rational.
No, I cannot address it by rationalizing. I cannot do that. It's not going to help. So here, look at the difference between these two. This one had 2 terms. It had the square root as 1 term if you want, and this is the second term. But this is a totally different story. So how would you think? Yes?
Can't you take the square root of X squared and the square root of negative? Can you not do that?
Okay, so let's talk about it because it's very important. The square root of a squared minus b squared does not equal the square root of a squared minus the square root of b squared, or just a and b. Does not. Because this is a sum or difference of terms. We can take the square root from a product, and we can write it as the square root of a times the square root of b. We can take the square root of a over b and write the square root of a over the square root of b. But when it comes to the square root of, let's say, 9 minus 4, this does not equal the square root of 9 minus the square root of 4. This is the square root of 5, and this is 3 minus 2. Also, the square root of 9 minus 4 is really this. So we have to perform the operations inside first.
We guess you can simplify on the square root.
Yes, how?
The difference is square root.
Yes, but I cannot take the square root of x minus 3 or the square root of x plus 3.
We have to get rid of the radical up top,
How do I do that?
multiply it by
I can't do that because I don't have two terms. If I get rid of it from the top, I will get it in the denominator. It will be the same thing.
do square.
I cannot square. It's if I tell you that I have $10 in my pocket, and I'll say, okay, well, let's square it.
I mean square, but it's not by
I cannot. Let me explain why. Let me explain why. So if I have 1/2 and I choose to square, is this the same thing with, is 1/2 the same thing with 1/4? No. So I cannot choose to square. So there is another technique that we used in this class for something like this. Do you remember? Okay, that's fine. Yes?
Forcing factor
Yes.
out
Yes, indeed.
would factor out. X
What will I
squared.
factor out? Exactly. In other words, try to change the quantity or the radicand, the quantity under the square root, into a product. Exactly. And what will I factor in the denominator? And I don't care for the constant, just the degree. What will I factor in the denominator? Indeed. Good. So what is left in the denominator? So please remember this type of limit is very important. So if I
2 minus 6 over x.
very good, perfect. What about the top?
It's going to be 1 minus 9 over x squared.
Perfect. Because now this is a product, I can simplify it. I can only simplify products or quotients. So this is the square root of x squared, and this is the square root of 1 minus 9 over x squared divided by x times 2 minus 6 over x. Okay, so now, remember what we just looked at a minute ago or 10 minutes ago was this. The absolute value of 2 minus x has two possibilities. Well, we have the same situation here. The square root of x squared is not x. It could be positive x or negative x. I will make a decision based on this. Because x approaches infinity, what will the square root of x squared be? Yes, it happens that this will be x. So this is limit as x approaches infinity from x the square root of 1 minus 9 over x squared divided by x 2 minus 6 over x. I don't know why I'm writing on the last squared millimeter.
I did the same thing.
There is no need. Yeah. Okay, so then of course we are going to simplify this, and I have limit as x approaches infinity from the square root of 1 minus 9 over x squared and everything over 2 minus 6 over x. Now I can drop the limit operator. Because now I apply the limit. So when I drop the limit operator, it means I calculate the limit. So, or I apply the limit operator to this. So what does the top, where does the top go to? Very good. Where does the bottom go to? What do we conclude? If the limit as x approaches infinity from this function is 1/2, what does that mean? Yes, y equals 1/2, horizontal asymptote at infinity only. We did not check the other one, so I can conclude just yet. Any questions? Any questions, please? Okay, we're done with the limits for now. So do I have to show we just did a problem like this? Do I have to show this one? You want me to?
Yeah.
Okay, perfect. So we have 2x cubed minus 8x squared minus 7 equals 0. We're asked to show that this has a solution somewhere using the intermediate value theorem. So the first step is to denote the left-hand side of the equation by f of x. I have to write this. And I have to conclude that this is what type of function? Because if it's not, if it does not have that property, I cannot use the intermediate value theorem. Yes. Continuous as a, what type of function is it? Polynomial function. Number two, I have to find an interval of 1 unit length, not wider, and I will put in the graphing calculator. And in y equals, clear whatever you have. And we put in 2x cubed minus x squared. Minus 8x squared, yeah, 8x squared. Oh, I always do that. I don't look. So 2, thank you. Thank you. Minus 8x squared, and then minus 7. And I go to second and table. And I'm going to put in 0, and 1, and 2, and 3. Okay, I'm stuck. Okay, can you come up with the interval?
Looks like it's between 4 and 5.
It may work now, we'll see. So can you give me the interval?
4 and 5.
Okay, good. Well, don't torture me if you have it. Very good, thank you. 4 and 5. And how much do we get for 4?
Maybe a -7. And then positive 43.
So I'll say by 1 and 2. From 1 and 2. And squeeze, not squeeze. IVT. I slept very well last night. I don't know why. By IVT, there exists a C in the interval 4, 5 such that f of c is 0. On Tuesday, the thunder and the storm woke me up at 2 a.m. and I couldn't go back to sleep till about 5 o'clock. So I thought I was recovered. Okay. Next question. We are given a graph. It says, do not graph the derivative, but find the intervals on which the derivative is negative, positive, or 0. So here's the function. What can we say about this function? We can say that it's increasing, and then it has a peak, and then it's decreasing, and then it has a peak, and then it's increasing on the interval between 0 and 20. So when is the derivative negative? Yes, between 5 and 15. The derivative is negative because the tangent will have a negative slope. So derivative less than 0 between what is this, 5 and 15. When is the derivative positive?
So 0 to 5.
Union.
Union 15. So
Very good.
5.
0, 5, union 15, 20. And where is the derivative 0?
5 and 1, sorry.
15.
15.
At 5 and 15, the slope is 0, so the derivative is 0. Any questions? Any questions? Okay. So it's positive between 0 and 5 union 15, 20. It's negative between 15 and 20 and 15, 5 and 15, and it's 0 at 5 and 15.
Why wouldn't it be brackets instead of parentheses?
Very good question. The intervals, so as you see, at this point is 0. It's not strictly greater than 0, so I cannot close anywhere. Because when we say positive or negative, we don't mean 0. We have to say positive and or 0. Good. Any questions? Yes,
So
Joe?
on that one right there, why do you write f of c?
So there exists a c, there exists a number c between 4 and 5. We call it c. You can call it a, you can call it b, or you can say there is an x value. If it's easier for you, you can. If you don't want to use c, it's fine. You can say by 1 and 2, continuous and changing sign between 4 and 5, there must be a number somewhere. You can say, just call it a number. You don't have to use c. We use c. You can say there is a value of x between 4 and 5 such that f of that value is 0.
If we write it out like that, we don't have to use any of this.
No, of course. I'm fine. Okay, find the equation of the tangent line to the curve. So we are given y equals the square root of x minus 2. We are given the point 11, 3, and we're asked to find the equation of the line, of the tangent line to the graph of this function at this point 11, 3. What do I have to do? Where is my starting point? What do I think of first?
Set up the difference quotients.
Yes, because I need y. What? What do I need and why do I do that?
Gotta find the slope.
Yes, very good. So the equation is y1 minus y1 equals the slope times x minus x1. This is the point slope form. Point slope form. I do have, of the equation of a line, right? Any equation. I do have a point which is 11 and 3, but yes, I do not have the slope. Because I don't have the slope, I have to find the derivative of this function. And what will I plug in to determine the slope? Okay, let me give you the idea. Let's picture the idea here in a graph with a figure. Ready? So I would like to graph y equals the square root of x minus 2. Can anyone give us a domain of this function? What do I have to write? You're on the right track, but it's the other sign. So what do I have to write first?
Oh, wait, no, it's 2.
So, yes, what do I have to write? There is only one student in the entire class who answers this square root for some reason, and I don't understand why. Why can we remember that we cannot take the square root from anything but 0 or positive? Nick was the only one who answered this, if I remember correctly. If I don't remember correctly, I apologize. So he's not lost. I'm looking at him, he's right here. He's not lost. So x greater to 2. So then the domain is 2 to infinity. So I want to graph this function. So here's the graph. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here's the graph. And at this point, 11, 3, I want to determine the equation of the tangent line, which is this. That's the tangent line. I want to determine this equation. I want to have y equals. I do have the point, but that's not enough. I have the point, but I don't have the slope. How do I determine the slope? Yes, Tom already said, find f prime, and then plug in what? Because if I find f prime of x, I will find the function. But what do I plug in? Where is the point? Exactly. So there are two options here. We find f prime of x, and then we plug in 11. Or from the very beginning, we find what? We have two definitions, not just this one. Exactly. Of what?
11.
Exactly. So it's pretty much the same thing. Now you decide which one you want to apply. It doesn't matter to me. You can say let's find f prime, and at the very end we plug in 11 and we get the number that we need to plug in here. Or you can say I don't want the function, I want to determine this. It's up to you. Okay, perfect. So limit, let's use the other definition. We used the h one last time, so let's use this one. X approaches 11 from what? F of x, which is the square root of x minus 2, minus, it has to be f of 11. F of x minus f of a over x minus a. So what do I get? Which one? Yes, very good. Okay, so plug it in. What do you think you're going to get? No, I hope not, because then the slope doesn't exist if it's undefined. So what do I get when I plug in 11?
Indeterminate.
Yes, which is exactly, of course. Which factor has to go away eventually if this limit exists? Perfect, x minus 11. Okay, very good. What do I do? There are two terms at the top, so there is no discussion here. Exactly. So the square root of x minus 2 minus 3 and x minus 11, the square root of x minus 2 plus 3 over the square root of x minus 2 plus 3. Yes, there is no thinking there. Okay, perfect. Then, so we get limit as x approaches 11. I will copy the denominator and wait for you to give me the numerator. Awesome. But what does x minus 2 minus 9 mean? And now I can drop the limit operator or apply the limit operator, whatever you want to say. The numerator is 1 and the denominator is? Good. So finally, I have what I needed. So it's right here. What is? It's 1/6. That's the slope of the tangent line to the graph of the given function at 11, 3. That is 1/6. So now I'm going to copy the whole thing and solve for y. Y minus 3 equals 1/6 x minus 11. Is everyone with me? Any questions?
Okay, so that equation gives you the slope.
This one gave us a slope and we put it in. So this will be the equation of the tangent line and we have to solve for y. So that's not enough. Ready? Yes. So 1/6 x minus 11 over 6 and plus 3. How much is negative 11 over 6 plus 3? I have to use the least common denominator, which is? Good. So I have negative, remember the negative in front of a fraction goes to the top. Negative 11 plus 18. How much is that? Very good. Plus 7/6. One more time. Can anyone tell us what this represents? What this represents? It's the equation. It's the equation of the tangent line to the graph of the square root of x minus 2 at the point
slope. Very good.
Right, because if I move the point here, it's going to be a different slope and a different equation. If I move the point here, it's going to be a different slope and a different equation. Is that clear? Is that clear? Yes? Questions? Good. Any questions? Moving on? Yes? Okay, find the horizontal and vertical asymptotes of the function. So what do I have to do now?